Hi everyone, welcome back to another session of the series Understanding and doing deep dive into the Transformers architecture. In this series, we are referring to the blocks by JLMR, and particularly we had to two segments earlier where in the first segment we tried to understand through a high level architecture of transformers. Then we in the second segment we dived deep into the what's the calculations going on in the encoder block. And now in this session we will be taking it forward from what we did last time. So in a nutshell, where we reached till the last time was that we had input sentence, then we converted that sentence into word embeddings, then we had multi-head attentions, and then through that we calculated the key query value pair for head of each attention, and through that we calculated the sum or generally the head that we were calling for each of the attention layers, and then we concatenated all of these heads and then multiplied by the weight matrix to finally get the sum that we were passing to the feed forward neural network. Now let's continue further. By doing this, exactly what is the thing that we achieve if we try to see from the perspective of what this particular attention mechanism did is, if you can see earlier we did had from one of the attention layers was we got to realize that it was connected to animal by a good score or by a good probability, you can say. However, using all of these attention layer from the fifth attention layer, I think it mentions the fifth attention layer, we are trying to we see that even the tired, like tired is related to it, and also street is related to it. So it's like with the combination of all the attention heads that we have, through that we will find what's exactly it refers to. It is attention, the attention or the context what to which the it belongs to. So we will do that for all the words, and for some of the words here you see like those are the words who are cut it into half or something like that. That is because we are not doing it for understanding, we are doing it for each and every word, but generally we are doing this thing for each and every token that we have. And sometimes these tire and d are two tokens. It's a one single word, but in tokens they are two. So yeah, moving forward, moving forward, particularly now, if we try to add all the tensions that we had, like all the tensions had, then we will see like for the different attentions heads, it's giving different probabilities or scores of it being referred or have attention through the it word keyword token that we had. Sorry for this, and particularly if we try to move forward, we are here. Yeah. So now deep diving deeper into like what before passing a word embedding into the encoder part, we are also how do we if we pass all these words, one of the things is in the attention layers we are passing all these words at parallel. It's not like we are waiting for one word then we will get output based on that we pass the second word, based on that we pass the third word. No, it's not like that. We are passing all the words at once to the encoder layer that we had. That if we are doing something like that, how do we understand that it was near street or it was near the tired or the animal or anything like that? So particularly for and in grammar, one of the very important things is the position of different words with respect to different words, because if the position differs, the meaning of the whole word or sentence is just change. So particularly to have that particular aspect reference of that aspect into the place, we what we do generally is we try to positionally encode the different words. For the first word that we had, we will positionally encode it with the uh, positional encoding that we had. For the second word that we had, we will positionally encode it. For the third word, we will positionally encode it to get the X3 vector. This is the word vector that we have, word embedding. Then we positionally encoded that particular vector, and then from that we will get that particular word embedding with the time signal. It's in simple words, it's words with the positions or the time signals that we are depicting here. So this is maybe how you can particularly see. So what we are doing is for the word that we had, we are then applying the positional encoding on the different word embeddings that we had, and then for we are combining or concatenate combining the data of positional encodings with the embeddings that we had. So this is the positional encoding for each and every different words that we have, maybe the places of different position of words with respect to this word. And then now we take that information of how this word is present with respect to the other words that are there in the sentence. And based on that particular thing, we will be passing into the encoder block that we had. And a lot of times, if so, this is what we are seeing for just for three words. What if we scale this thing? So, what if we try to visualize this thing at a very high level in to find to see what exactly it is looking like? So, in this, like how they have mentioned, like in this following figure, each row corresponds. So, for each and every row, they are saying it's a positional encoding of a vector. So the first row should be the vector we have added to the embedding of the first word in the input sentence, and each row contains 5 and 2 values, and each of the values between 0 and 1. And 0 and 1 you can easily figure out based on the color coding of those things. So this is a so each of these rows has around 5 and 2 values, and we have around 20 rows. And a lot of times in positional encoding, what we are doing, we are also doing positional encoding by using generally by using two functions. For example, if you see there is a line in between, so what they have mentioned here is for that's because for left half are generated using the sine function, and right half is generated by another function which is generally cosine in this case, and then those particular both of these things are concatenated from each of the positional encoding vectors. So particularly what they did is in one of the tensor to tensor implementation of transformer, what they try to do is they how they try to weave through these signals was uh, generally through like alternate usage of this thing, that it doesn't directly concatenate those things but interweaves the two signals that we have. And then particularly residuals. For residuals, I think you might be understanding residuals are similar to what's happening is a lot of times the input from one of the layers is what we are passing to the next layer, and similarly we are doing that thing. But a lot of in this particularly on a lot of places what we are doing, we are also trying to make the residual connections to pass to try to fetch if we are maybe having much more information through that what we if we have much more information in the earlier step that might not have been captured through the self attention layer. So we what we are doing is we are passing the positional encoded word embedding to the self attention layer, and then processing trying to find the head from the multi-head self attention layer, and then adding a normalize. So at that particular point of time, we are first is we are passing the attention head, and also we are passing the positional encoded word embeddings, and then adding and normalizing both of these information from both of these into the layer that we have, so that it helps us in realizing from if we would have missed out some information, maybe if we try to do it, maybe we are able to capture that thing in a better way if we again pass it through some of the layers. And then particularly these residual connections are also made when we did adding and normalizing and then passing to feed forward layers and processing them further, and at the same time we also pass this layer to the addition and normalizing, so that we are also getting these particular values from the earlier uh, calculations that we did. So now if we try to visualize this thing in sense of what are the different calculations we did, what are the different things we calculated at different steps in a granular manner, this is what we did till now. particularly, sorry for this. Where do we go? Sure. Yeah. So here we are. So particularly what we did, we had two words. We had two words, two different words. Then we positionally encoded those two words. Then to find positional encoded word embeddings. Then we pass positional encoding word embeddings of these two words to get the attention head. And for the attention head that we have got, now we are passing it to the addition and normalization layer, in which we are also passing the residuals or the word embeddings with positional encoding. So we are passing the first this one and then these two vectors into this thing for addition and normalization. In addition, we are doing so that we get that particular information, and then finally we are doing normalization. So once we do that thing, I'll say we can say that thing has updated Z1 and updated Z2. Now we are passing these updated Z1 and Z2 to the feed-forward neural network that we have. And then for the output that we get from that and the Z updated Z1 and Z2, then we are again adding and normalizing all these values. And now if we try to stack everything together to particularly see what is happening, now we are trying to zoom out of what we understood or what we try to, and now we are trying to see the whole picture of how everything is running. So what we have done till now is what we looked through one of the encoders block. And now we have stacked one more encoder block on top of the output of the first encoder that we have. And then from the output of the encoders that we had, we stacked one decoder block. And on top of that decoder block, we stack another decoder block and then finally passing the output to a linear and then softmax layer. So this is on a very high level what we are doing in a normal transformer module, in which what the main for each and every main encoder block, if you try to sum up, four steps we are doing. First is we are doing positional encoding, then we are passing to the attention layer, then we are normalizing those values that we have got, then we are passing to the feed forward neural network, and then again adding and normalizing those values to finally pass the output that we had. And similarly, the same process we are repeating here, and then we are passing to the decoder. And in decoder also, generally what we are doing is first we are passing the inputs or the outputs that we had to the attention layer, and then adding and normalizing those values. And then this is the place where we are differing in this. Particularly what we are doing is we are passing the outputs that we have got from this decoder block and the outputs we got from the encoder block, and then applying a attention mechanism over that, so that we are able to find relations of how input and output, or how each and every word is having attention with respect to input and outputs that we had. And then finally adding and normalizing, then the same thing passing through feed forward neural networks, and then adding and normalizing. And at the same time having maintaining those residual connections. So I hope this thing was clear to you. In case if you have some doubts, maybe you can put those things in comments, or maybe go through J's blog. In the next session, we are going to discuss much more about the decoder side of this thing. Thank you very much for this session. I hope you understood this thing.